This is our KNS 1633 Engineering Mechanics Group project, which requires every one of us to design and create a model of bridge by using popsicle sticks. The most stable and strongest bridge design will be selected by us among our designs after analyzing and testing. Our group name is Phonics Group, and the group members are Thian Chee, Esther Lo Jia Hui, Dayang Nurrasyidah, Binti Awang Abdurahman, Muhammad Firaaz bin Muhammad Fadzli, Chaldi Sudin, and Kathrine Nyuk Chee. Our course instructor is Dr. Idawati Ismail. First of all, we have to know what is truss. Truss is a load-bearing structure made up of series of wooden or metal triangles. As we know, triangles are one of the best geometry for load distribution because they take force from a single point and distribute it across a wide base. For example, in a truss bridge, the mass of transport are well distributed over the bridge. The individual members of truss intersect at joint. The most interesting part of truss is that it can carry heavy load even though the materials used to create the bridge is small amount in quantity. When a load is applied, the members of truss experience tension, compression, or even zero forces. The types of truss design selected by our group are Warren truss, Pratt truss, hole truss, K-truss, camelback truss, and double intersection Warren truss.
Hi everyone, my name is Thian Chee and my metric number is 77004.
Hello guys, today I will present my bridge model.
Hi everyone, my name is Esther Lo Jia Hui and my matrix number is 74746. I'm the group member of Phoenix Group.
Hello everyone, my name is Kathrine. Today I'm going to talk about Pratt Truss Bridge.
Hello everyone, my name is Dayang binti Abdurahman with the matrix number 73411.
Assalamualaikum and hi everyone. My name is Mohd bin Fadzli 73610 from Group Phoenix.
So now I'm going to present my bridge design, which is hole truss bridge. The hole truss is usually being used in beam, roof supporting, and the design of bridge. The hole truss was firstly designed by William Hall in year 1840. The hole truss consists of chords, vertical members, and diagonals. The vertical members is usually built with metal because it is in tension, while the inclined member is usually built with timber because it is in compression. The materials and equipments that I use for my model bridge design are popsicle sticks, hot glue gun, hot glue sticks, chairs as my support in the testing process, and brick as the load also in the testing process. The dimension of my hole truss bridge design is 1130 millimeters in length, 120 millimeters in height, and 110 millimeters in width. After creating my bridge model, I proceed to the testing process. I put the bricks at the middle of the bridge and increase the mass of bricks gradually, and finally at the 8th bricks, my bridge undergoes deformation and collapse. So my bridge can carry maximum around 8 bricks, which is around 20.8 kilograms. This is the hole truss member behavior when load is applied. There are 5 members experiencing zero forces, which is the member at the middle part and 2 members at both ends of the truss. At the middle part, there are 3 members at the joint which consists of two collinear members. Since there is no external force and support exerted at that joint, so the third member is zero forces member. For the two zero forces member at both ends, this is because there is no support and external forces exerted in that joint, which consists of two non-collinear members. So for the vertical members of the whole truss, it experiences tension, while the diagonal members experience compression. Since when a load is applied to a bridge, the bridge will bend, so probably the upper parts of the bridge will experience compression, while the lower parts, which is the lower deck of the bridge, will experience tension. The advantage of whole truss is economical. This is because the quantity of materials used is less, and in last time, people built the inclined members of whole truss bridge using cheaper timber since they are in compression. It is a simple and light bridge design, but it can carry a heavy load. In the future, it will be easier for maintenance and repair since it does not involve a complex structure. The disadvantages of the whole truss is longer build time because the angle and length of truss members in whole truss bridge must be very precise and accurate. The major disadvantage of whole truss bridge is its longer diagonal members. Can we imagine that what will happen if we try to apply force on a longer and shorter chopstick? For sure, the longer chopsticks will break more easily. We can say that buckling happens more easily at the longer diagonal members. Besides, if the whole bridge is not designed properly, wastage of materials will happen when unnecessary members are designed and created on the whole truss bridge. So that's all for whole truss. Next, I will invite my friends to continue our presentation.
I will present my wooden truss bridge, and this is the bridge that I selected to design in this project. I will present the wooden truss, and for wooden truss, it is a simple truss. It is either only consists of isosceles triangle or equilateral triangle. There is no any vertical component in the triangles. It is a simple truss, therefore the cost of construction in real life is lower than other truss design. The equilateral triangle will distribute the load into tension and compression only. There is no zero force member. This is the sample of the wooden truss. The materials and equipment I use when designing my wooden truss bridge is the standard popsicle sticks, hot glue gun with the hot glue stick, white glue, the plastic stool tray as my support of the bridge during testing, and the red brick as my load in the testing. The mass of the red brick is around 2.27 kg. About the dimension of the wooden truss, the upper deck will be 1060 mm and the lower deck will be 1160 mm, whereas the width will be 113 mm and the height will be 100 mm. Next will be the wooden truss behavior when there is the load applied on the truss. This is the load that apply, and the slanted member that under the load will undergo compression. The red color is the compression member, whereas the other slanted member that is not under the load apply will have the tension and compression member, whereas the horizontal member that on the upper deck and the lower deck both will have the tension member. And over here, the both end of the wooden truss bridge will have the support. About the testing result of my wooden truss bridge, the first picture is the bridge is supported by two plastic stool chair, and the lot that I use is the red brick. The second picture is show that the wooden truss bridge can sustain the mass of one red brick, which is 2.27 kg. And the third picture shows that the truss can sustain the load of two red brick. And the fourth picture shows that when I apply the third red brick, I found out that it starts to deform at the left end part of the bridge, and then it starts to collapse and break. And this shows that the wooden truss bridge that I designed can sustain the maximum load of two red brick, which is the total load of 4.54 kg. The advantages and disadvantages of the wooden truss is, for the advantages, the load is spread evenly between the members, and it is a simple design. Therefore, in real life situation, the cost construction of the wooden truss bridge will be lower compared to other truss design. Whereas for the disadvantages, it will have a poor performance if under the concentrated load, and the additional members will lead to increase in constructability. Thank you.
Pratt Truss Bridge. Pratt truss is firstly developed by Caleb and Thomas Pratt in the year of 1844. Originally, Pratt truss is used to replace the railway bridge, which is made of stone or wood. The Pratt truss is characterized by having its diagonal members slanted down towards the middle of the bridge span, except for the end diagonals. Under such structural arrangement, when subject to external loads, tension is induced in diagonal members, while the vertical members take compressive forces. Hence, thinner and lighter steel or iron can be used as materials for diagonal members so that a more efficient structure can be enhanced. The model of Pratt truss bridge is built by using standard popsicle sticks, hot glue, chair as the supports, and red bricks as the loads. The Pratt truss bridge consists of a lower deck with 1026 mm and an upper deck of 912 mm. The height of the Pratt truss bridge is in 114 mm, and similarly, the width of the Pratt truss bridge is also 114 mm. During the load test, red bricks are used as the load. Each red brick has the mass of 3 kg. The Pratt truss can only sustain 5 red bricks before it collapses. Hence, we can say that the maximum load applied to the Pratt truss is 15 kg. When the load is applied to the center of the Pratt truss, we can notice that the vertical members, which are in red, are in compression, while the diagonal members in yellow are in tension. And there are also two members in green are the zero forces members. There are several advantages to use Pratt truss. Firstly, the design of the Pratt truss is simple, so it is easier to be built. Besides that, Pratt truss can also reduce the cost of the structure. Pratt truss is more suitable for horizontal spans, in which the force is mainly in vertical direction. The biggest drawbacks of the Pratt truss is that it is only suitable for vertical load. That is all from me. Thank you.
I would like to present about Camelback Truss Bridge. First of all, I will talk a little bit about Camelback Truss history. Camelback Truss Bridge became common from 1870s until 1930s. Two examples of this bridge are the Traffic Bridge in Saskatoon, Canada, and Woolsey Bridge in Woolsey, Arkansas. The State Highway Commission, which only made use of this bridge at long crossings, used the camelback variant as the center span of Nash Country Bridge 271, which is erected over the Tar River just east of Spring Hop in 1921. This is the concept of camelback truss. The camelback truss is a subtype of bucket truss, which is a subtype of a Pratt truss, while some refer to any truss with a curved or polygon top chord as the camelback. But the more strict definition for camelback truss is it is the Pratt truss with a polygonal top chord consisting of exactly 5 segments. These are some materials and equipment that I used to construct the camelback truss bridge model. First, I used the standard popsicle stick as the main material for the bridge construction. I also used glue gun and glue stick as the adhesive for the brick joint. I used the chairs to be the support for the bridge during the testing, and also 2.4 kilogram brick as the load for the bridge testing. This is the dimension of camelback truss design. I made the design with a length of 1100 millimeter, and maximum height here is 270 millimeter. The width is 230 millimeter. This is the behavior of camelback truss member during the testing. 2 support placed at both ends of the bridge, and when the load applied on the bridge, there are few members with the green color, which are in compression, and the members in the yellow color are in tension. There are also 2 members with the blue color here, which is known as zero truss member. About the testing result, first, I used the chair as a support at either end of the bridge. 2.4 kilogram bricks used as the load for the testing. I put the load slowly onto the bridge. As we can see, the bridge start to deform at the top right after 9 brick has been placed on the bridge, and the brick collapsed and broken. This shows that the camelback truss bridge that I designed can sustain maximum 9 bricks. Hence, we can say that the maximum load that can be held by the bridge is 21.6 kg. As other bridges, camelback truss bridge also has some advantages and disadvantages. For the advantages, first, camelback truss use less material to design. This makes this truss as a cost-saving truss due to the amount of material needed to construct the camelback truss that can be reduced. Other than that, the advantages of camelback truss is it is able to have a span long distance without affecting its strength, and the load applied on the truss will be evenly distributed along the beams into tension and compression. Whereas, for the advantages, camelback truss bridge is complex to construct. Each and every piece needs to fit perfectly in order to perform its function, and anything less will mean that the bridge simply does not hold the load. Other than that, it needs high maintenance costs. This is because camelback truss can wear out easily due to the climate change. The maintenance cost of so many parts can be expensive. A truss bridge, like any load-bearing structure, will require regular and detailed maintenance. So many parts to look after can mean that this is expensive, and not to mention the time consuming to finish the maintenance of the truss bridge. That is all from me. Thank you.
I would like to present about double intersection Warren Truss Bridge. First of all, I would like to talk about this double intersection Warren Truss Bridge. It is composed of isometrical truss with double intersection and known as cancelled truss, with which dispenses with vertical pieces except perhaps at the ends or at the first bearing points from the ends by Whipple 1000 1846. These are the example of double intersection Warren Truss Bridge. First, steel bridge for BNSF Railroad over Verdigris River, Oklahoma on 1960. Next, this is famous, Washington Crossing Bridge. These are the materials and equipments that are used for the bridge. First, standard popsicles as the main material for the construction. Next, glue gun and glue stick and cable tie as the adhesive for the bridge joint. Next, chairs as a supporter during the testing. And lastly, 2.6 kg brick as the load. These are my dimension of my double intersection Warren Truss Bridge. I make the design with the length of 1030 mm for the lower deck and 930 for the upper deck. My maximum height of my bridge is 107 mm and the width is 114 mm. These are the behavior of double intersection Warren Truss members. Firstly, there will be two supporters at the end of the bridge, and when the load is put on the bridge, there are a few members exist, which is the green color is the compression and tension for the yellow color, and there will be no zero forces. For the testing results, I used the blue chair as the support. Next, I put a load which is a brick with 2.6 kg on the bridge slowly. After that, I put another load on the bridge and the bridge begins to collapse. Hence, this bridge can only hold up to 5.2 kg load. These are the advantages and disadvantages of double intersection Warren Truss. For the advantages, loads are distributed evenly between tension and compression throughout the beams. Next, it has a simple design with just intersection without any vertical members. Whereas for the disadvantages, it is a complex bridge to construct. We have to piece each and every stick perfectly in order to make the load distributed evenly. Last, it is not applicable for horizontal load. It can only carry vertical load only.
Okay, my name is Chaldi Sudin, metric number 74389, and the bridge model that I built is the K-Truss bridge model. Okay, this is my bridge, and the dimension of the bridge model is 1026 mm for length, and the height of 134 mm, and width with 100 mm. Okay, here are the materials that I use for building the bridge and also for testing the bridge: popsicle sticks, concrete cube, hot glue gun, and the glue stick. Okay, K-Truss. The K-Truss was designed by Phelps Johnson. The K-Truss was basically a variant from the Parker truss. The idea of the K-Truss is to break up the vertical members into smaller sections. The shorter a member is, the more it can resist buckling from compression. Okay, here are the first behavior in the K-Truss bridge. The green line represents the compression, while the red line represents the tension. So, in this truss analysis, there is no zero force member for the K-Truss bridge. So for my testing results, the bridge bended the moment that I released the concrete cube and slipped from the concrete block, as you can see from this picture. The bridge broke at the joint part where the glue was applied to connect the member. The mass of the concrete cube is about 6 kg, while the mass of the metal plate is around 2.5 kg. So the bridge maybe can only support loads below 8 kg. So the advantages and disadvantages of the K-truss. The advantages is, first, it reduces the compression in vertical member by breaking it into smaller parts. Second, it is possible to reduce the steel and cost if the design was made efficiently. And the disadvantages of this bridge is it is slightly more complex than other truss bridge, and it is also increases the constructability due to additional members. So they will do more checking while constructing this bridge. Okay, that's all from me. Thank you.
Before selecting the best bridge design, first of all, we have to identify the characteristics of a good truss bridge design. Firstly, the cost of bridge construction must be low. To reduce the cost, the bridge design should minimize the quantity of materials used to build the bridge, but at the same time, maintain the high quality of the bridge. Secondly, a good bridge will last longer. The durability of bridge is important to reduce the cost of maintenance. To maintain the durability of the bridge, materials with good quality should be used. Thirdly, the bridge build must be strong enough to carry loads to guarantee the safety of bridge user. The engineers have to design the bridge with a good distribution of force. Snapping and buckling must be avoided. Fourthly, the bridge design must be simple but strong at the same time. This is to reduce the cost, materials, and duration on construction. Hence, the structure of bridge should not be too complicated, which may increase the risk of mistakes happen. So, by considering the characteristics of good truss bridge design, our group decided to choose the camelback truss bridge as our best bridge design. The reasons why we choose the camelback bridge design is because the camelback bridge maintains a straight or level highway which threads through the truss. One advantage of the truss is cost saving by reducing the amount of material needed to construct it. This is because the truss is progressively deeper as one reaches mid-span. Since the bending moment in a simply supported beam is greatest at mid-span and distributes as a parabolic curve, the camelback upper truss chord is also curved, composed of short, straight tangents. This curve in the upper chord means that the bridge becomes progressively stronger in resisting bending moments in parallel or instead to the increase of bending moment as mid-span is reached. The bridge narrows down near the piers or ends of span so that it is strongest only where it needs to be, and cost and materials are reduced or minimized as compared to a truss having a constant height, which by necessity has more strength than needed in the ends approaching the piers. As we can observe from our testing process, the camelback truss bridge model can carry the heaviest load compared to others truss bridge design. This is the most important part, at which the load can be evenly distributed throughout the bridge, especially during the traffic jam. So it is very safe to be used for heavy traffic roadways. Besides, the camelback truss bridge is able to span long distance without affecting its strength. It is also a lighter structure compared to other bridge design such as arch bridge and suspension bridge due to the less materials being used. So, we decide that the camelback bridge is the most suitable and strongest truss bridge design. That's all the presentation from our groups. Thank you.
Oke.
I never seen. Ini kalau kita kerja. Kalau kata,
Mau sepatu pun.
mau kasih kata?
Patah gagal.